Hello everyone. We're going to do a little review of the phases of the moon. You want to make sure that you have your notebook out ready to take notes, and anytime you see any bolded or underlined words, those are the words you want to make sure you get down in your notebook. Alright, and make sure that you pause anytime you need to actually take the notes or go back and listen to something that you might have missed. Right, so here we go. Quick intro. The moon is almost 385,000 kilometers away from the Earth on average. It follows an elliptical path around the Earth, so it's going to be a slightly different distance, just like the Earth is from the Sun, depending on where it is in its orbit. The moon is always in motion. It revolves around the Earth as the Earth is revolving around the Sun. The phases of the moon, eclipses, and tides are all caused by how the Sun, Moon, and Earth are positioned in relation to one another. The motion of the moon takes the same amount of time for the moon to rotate on its axis as it does to revolve around the Earth, 27.3 days, which means a moon's year, right, the amount of time it takes to revolve around the Earth, is equal to the same amount of time it takes to revolve around its axis a moon day. Moon years and moon days are the same. So if you need to pause to write that down, go ahead and do that. Okay. This is the reason why the Earth only sees one side of the moon. If you wanted to see the other side, you'd have to get in a spaceship or use a satellite to actually take images of it. The near side always faces Earth, and the far side always faces away from the Earth. Okay, so go ahead and pause if you need to write that down. Okay, so this is just a quick image to kind of demonstrate what I'm talking about. The moon is revolving around the Earth, and it's also rotating very, very slowly, so that it's always turning slightly inward. It's always facing the same direction, always looking at the Earth. Alright, phases of the moon. Right. Moon shines because it reflects sunlight. So it's really the sun reflecting off of the moon that we see. Right. The phases are just the different shapes of the moon from the angle we're seeing it on Earth. Right. So if we look at this diagram, we can see a new moon is when the sun's directly behind the moon, shining on the side that we can't see. Right. So you can see the side that's facing Earth is in darkness. The opposite side is completely in light because it's facing the sun. And as the moon slowly revolves counterclockwise, we start to see a sliver of the lighted part on the right-hand side of the moon. That's what we call a waxing crescent when it's starting to grow. When it reaches about half, we call that the first quarter. Again, it's on the right-hand side, so we know that it's waxing. And then it grows up to a waxing gibbous. That's when it's a little bit more than half. Eventually we get the full moon, and notice the order: sun, earth, moon. And the reason that the Earth isn't blocking the light from the sun is because this path is slightly tilted. Right? So the moon is slightly actually above the Earth at this point. So it's not actually blocking light from the sun. That would be an eclipse if that happened. Right, so we have a full moon. When we go from full moon, we start to see a waning phase. Right, so as it moves away from the full moon, we get a waning phase, waning gibbous when it's slightly more than half, and we get to the third quarter when it reaches the halfway mark. And this time we're seeing the light on the left-hand side instead of the right-hand side. If we're facing from Earth, we would see darkness on the right and light on the left. And then we'd go to a waning crescent, and then all the way back to the new moon again. Alright, what causes the phases? We just talked about phases caused by the relative position of the Earth, Moon, and Sun. As the moon revolves around the Earth, different parts of the moon become lit up. And if you need to pause to write that down, go ahead and do that. The phase we see depends on how much of the sunlit half of the moon is facing the Earth. Alright, so exploring the phases of the moon. The lit part of the moon always points towards the sun, So there's always half of the moon being lit up. It's just the angle that we're actually seeing it at depends on how much of the lit half that we see. Right? So when it's waxing, light is on the right. Right? This would be a waxing phase. So we see the light on the right, dark on the left. When it's waning, right here, we see a shadow on the right. We see a light on the left. So you can look up at the moon at any given day, not know what it has been in the past week, but you can figure out whether it's waxing or waning based on what side the light is on. Make sure you write those down. All right, can you identify the phase? If you need to pause as I'm doing this, if you need more time to think, go ahead and do that, but I'll pause for a second so you can think about this. What phase would this moon be in? Think about what side the light is on and how much of the light is being shown. It would be a third quarter or a last quarter, right? So it would be in its waning phase, the light is on the left, and it's halfway being shown, so it's a quarter moon. What about this one down here in the corner? This would be a waxing crescent. The light is on the right, so it's waxing, and it's a crescent moon. This would be a full moon. This would be a waning, light on the left, and it's gibbous because it's more than half. This would be a first quarter. The light is on the right, it's half of it's being illuminated. A waning crescent, light on the left, crescent moon. A waxing gibbous, light on the right, more than half. This would be a new moon. You don't see any illumination. All right, I would suggest maybe going over this one more time. If you got any of those wrong, try it again, see if you can get them right. They're good practice. All right, so the cycle of phases, they go through a phase of waxing and waning. Waning, we see the light on the left. Waxing, we see the light on the right. It always cycles from new to full and back again. All right, so the cycle of phases, there are 29.5 days from a new moon to the next new moon. Slightly longer than it takes to actually orbit around the Earth, and this is just because of the slightly awkward elliptical path of the moon and the fact that it's slightly tilted. So during these 29.5 days, the Earth sees more and more of the lighted half of the moon until the full moon, and then less and less of the lighted half of the moon. Right, the time of the moon rising and setting depends on the phase that it's in. It rises in the east and sets in the west because of the Earth's rotation. And it'll rise usually about 50 minutes later each day of the cycle. Right, so during a new moon, it will rise at sunrise with the sun and set at sunset with the sun. And during a full moon, it actually will rise during sunset and set during sunrise. And this is just a good diagram to show kind of how it's viewed from the Earth as it's orbiting. Notice that it's at a tilt, which is why we don't get an eclipse every single cycle of the moon cycle. It's actually slightly above or below the Earth, so it's not being blocked by the Earth's shadow. Right, but you can see when the sun is over here, the person here on the Earth, if her face represents the Earth, would see darkness. Right, so make sure you got some good notes here, and then go ahead and try the moon phases check and see how you do. Good luck. Have a great day.